Hi there, everybody. Today we are going to tackle absolute value equations. And I hope I didn't scare you with the word tackle. They are a little bit more complex. They're not insurmountable. If we think back to what you learned last year when you studied absolute value, we studied how to compute absolute value. And if you look at these, I think most of you would be unchallenged to find the answers. So the absolute value of -7, 7, absolute value of 12 is positive 12. Absolute value of -4, and this little negative outside says take the opposite of the absolute value of -4, which is -4, because the absolute value of -4 is 4. 5 minus 8 would be the absolute value of -3, which is 3. What is absolute value? If you remember how we defined it last year, we defined it as distance from 0 on the number line. And this will go in your notes. If the absolute value of x is 8, what is x? I think you could probably reason mental math that would be 8 and -8. Both are correct solutions to the absolute value of x. In words, what we're saying is the distance between x and 0 is equal to 8. I can go 8 units this way, and I can go 8 units this way. And either one of those says my distance is 8. To solve absolute value equations, you first isolate the absolute value on one side, and then you establish two cases. And we will talk about how to do that and why we do it the way we did. Down at case 1 in your notes, it says the absolute value of A is B. So I'm kind of considering positive in this case. I'm saying, well, then A could just be whatever the answer is. Or we're going to say the absolute value of A is -B. Now, the reason that we do it this way is because mechanically it's easier to set this up this way than to say what was actually true in this case. X was either 8 or the opposite of X was 8. So this really comes from the fact that we're saying the opposite of whatever was there is equal to B. Same thing, I can just multiply both sides by -1 and I would get -B. And you'll see how this works when we do these. If I'm looking at this absolute value equation, I can think about it mental math, and I can probably reason out what I want it to be. If you look down at what it says in words, you don't have that there, but I would like you to write it out, because it's saying that the distance between x and 10 is 6. I want to be 6 away from 10. Well, 6 away from 10 on this side is 16. 6 away from 10 on this side is 4. Either one of those values, 4 or 16, would work in this case. Let's see how we do that algebraically so you can use this model for the rest of your problems. So you set up the two cases, so either x minus 10 equals 6 or x minus 10 equals -6. Now that's because we're saying either x minus 10 equals 6 or the opposite of x minus 10 equals 6. But mechanically, algebraically, it's easier to do this, and they are equivalent if you think about multiplying both sides by -1. And the reason I show you this is because later on in this unit, we're going to have to use this a little bit. So I want you to kind of start understanding where I'm coming from. So obviously, if I solve those, I get 6 or 4. It is very important. It is actually essential that you check your absolute value equations, and you'll see why in a couple minutes. So if I check the 16, 16 minus 10 equals 6. Yes, the absolute value of 6 is 6. And in this case, I get 4. So 4 minus 10, the absolute value of -6 is 6. So the next problem, why don't you pause here and try this on your own and come back and check with me. I'm going to go ahead and set up my two cases. So I get 3x plus 5 equals 7, and 3x plus 5 equals -7. 3x equals 2, x equals 2/3. I get 3x equals -12, and x equals -4. I have two answers I do need to check. I'm going to go ahead and I'm going to say, is it true that 3 times 2/3 plus 5, the absolute value of that equals 7? Well, 2 plus 5 is 7, and the absolute value of 7 equals 7. On the other side, for x equals -4, I get 3 times -4 plus 5 equals 7. So is negative 12 plus 5 equal to 7? Yes, the absolute value of negative 7 equals 7. Absolute value is always positive. We know that. Now you can have an absolute value problem that might not work out to be positive, but the absolute value, strictly speaking, in and of itself, if you look at these bars, signifies a positive value. So this is not possible. It has no solution. If you get to this point in your equation solving, you should know that is true. Your answer is the empty set. If you look at the example shown below, I start to solve it. I remember I want to isolate my absolute value. So I would subtract 8 from both sides, and I get 4x plus 3 equals negative 5. There's no answer to that. Cannot happen. You're never going to have absolute value be negative, not even imaginary numbers. So we're going to use our little process here. If you want to stop and pause here and try it on your own, that would be great. So coming back, we would do 2x minus 7 equals 9. I'm going to set up my two cases. 2x minus 7 equals 9. 2x minus 7 equals negative 9. X equals 8. Or x equals negative 1. Can't forget my lovely check. I'm going to show my check. I'm going to actually do it with the original equation. 2x minus 7 minus 5 equals 4. Plug in my 8. 16 minus 7 minus 5 equals 4. And 16 minus 7 is 9 minus 5 equals 4. And so I get 4 equals 4. These are not formal checks. If you're asked to do a formal check, you can make it, neater or whatever you need to do. All right, so 2 times negative 1 minus 7 minus 5 equals 4. 2 times negative 1 is negative 2 minus 7 minus 5 equals 4. Negative 9 minus 5 equals 4. And 9 minus 5 equals 4, check. So let's look at example 5. This says two cases with one solution. I can go ahead and set it up using my two cases. So I'm going to have 3x plus 2 equals 4x plus 5, and 3x plus 2 equals, got to take the opposite of all that stuff. So that's going to work out to be minus 5. Don't forget that. You can pause here, try it on your own. On this side, I would pretty easily get x equals negative 3 and x equals negative 1. I have to check. When I check this, I get 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. Well, I'm going to get the absolute value of negative 7 equals negative 7. No, not happening. So what do we write here? We write reject. You need to show this. You need to show that it is a rejected answer. If you just don't write it at all because you know it's not going to work out, you're going to lose credit. You have to show an algebraic solution that shows why you are rejecting it. And then you're going to check the second one, which is 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. And so I'm going to get 1 equals 1 here when you check it down. Okay, this is your final answer, the only one. This is a reject situation, and you need to actually write, I am rejecting you. Moving on. I'm going to have you actually try that problem, just because, you need to work with the fractions and not have me work with the fractions. And I want you to look at example 7. I want you to see how you would set that up, and you will work on that in your table groups tomorrow. Also, I would like questions here, so hopefully you've jotted down some questions along the way. If not, and anything is standing out in your mind, I would like you to write a hot question. So everybody should come in with a higher order thinking question tomorrow to discuss in your table groups along with example 6 and example 7, and you are good to go. Have a wonderful evening.